Thank you. And yeah, good morning, all. So I am Aslam from Avin Systems. I'm very glad to be here and talk about something which is becoming very central for all of us. And even the preceding speaker spoke a topic something very similar. So I'll be talking about Gen I for a smarter AutoSAR process and a spice automation. So this is actually prepared by my colleague, Mr. Niant Hebar. You can see his name, but unfortunately, due to visa reasons, he couldn't join us here. So I'm representing him and I'm presenting it on behalf of him. So yeah, it's a bit slow. Looks like it's yeah. So before we jump in, a quick context: who we are. So as I said, I'm from Avin Systems. So we are a product and service company. So from the product, we offer AutoSAR classic products and bootloaders, and engineering services. We offer both on the middleware and the application development, and then also AI related things. That's what one of the topic that we are going to talk now, and then also on the process compliance. So I'm not spending too much time here. I will just go to the next slide. So first is like why this topic is of relevance now. So as the automotive software is becoming extremely complex, but all the standards like ISO 26262 or ASPICE, we have to follow the strict processes to get compliance, and it is indeed required also to meet the safety. So this creates a tension here because more the complexity means more the compliance effort, but at the same time the timelines are shrinking. And that's where we have the question like how we can leverage the AI for a faster development life cycle without failing any compliance or like meeting all the compliances required. So to start with, like let's look into the different problems that we are facing and the different problems that can be addressed here. So one is of course the manual effort. So today our engineers are spending like weeks of effort writing many test cases, like maintaining them, establishing the traceability all manually, and it is slow and a repetitive process. And the interpretation of different engineers on the different requirements will also lead to a quality inconsistency because a person A will read it in a different way than person B. And then there are still automations available. I don't say it is like completely manually done. Even now, there are many automations available, but there are many limitations because the current automation frameworks do not understand the requirements which are written in a natural language, and it won't even understand the boundary conditions, and it will miss the edge cases. And the another problem is the traceability drift. So as we have to maintain uh, the test cases even after like the requirements will be getting evolved during the period, and even the test cases will be like changing, it will tend to break the traceability over the period, and this also involve like a manual intervention now and then to make sure that things are maintained properly. And another problem is the no auto remediation. So whenever there is a problem, once you build the software, once you integrate it, you will face numerous issues, and you have to sit and debug. Not debugging like you have to identify why it is failing, why these issues are coming now, maybe some compiler options that you have set wrong, and you tested it in a different environment. So all these need people to manually analyze it. So what we did, so we have introduced the Gen I into the ASPICE workflow. So nothing new, the same workflow from C1 to C6, but we built a connected workflow where we leveraged the Gen I to get a better result in an optimal time. So let's take an example. the connection from C1 to C6. So here the stakeholder requirement specification. So here we are referring, since we're taking it as an AutoSAR, we are taking the SWE software specification from AutoSAR as a stakeholder requirement. And from that, the AI will parse it and create an internal stakeholder requirement. And then from that, it will create a unit requirement specification. I will show it in little more detail in the coming slide. And that will act as an input for the SWE6, where from the unit requirement specification, the test specifications are created. And from the test specification, even the scripts are created. And then that has applied on your code, which is manually written at the moment. It's like the static code or like your stack. And then the test is performed and the reports are generated again with the support of AI. So this is the connection from C1 to C6, and similarly between the architectural design to the integration testing, and for the unit design to the unit testing, similar methodologies are applied. So the second stage, it's more on the MBD part, where we take the model-based models for as an input, and test specifications or scripts are generated. And for the unit testing, the code is taken as an input, and the test scripts are generated for that code. So a little more insight to it. So in the first step, as I have mentioned, we take the AutoSAR SWS specification that we are considering here as a stakeholder document, and that is being parsed and then taken all the requirements from the document. So it can be a single document or it can be different multiple document. So for example, the transformer specifications are spread across different document. And then the created internal stakeholder document is converted, like decomposed into individual unit requirements. So for example, there will be requirements telling that you, once there is an issue, you have to shut down something and you also have to log DTC. So here we break them. So we have to create like a single atomic requirement out of that and then perform the classification, like whether it's testable or it is just an information or it is an input for your architecture. Then these unit requirements are classified, so it will have all the testable requirements, and from that you will take the testable requirement and create a test specification, how those testable requirements can be tested. And this test specification will act as an input for the code creation. So the code C code is generated looking into the test specification, and also it will create the stub code. So you might be testing some other modules like by just stubbing them. So even that will be created, and then that you will apply it on your static code and generate the reports again by automation. So you will have the log which will be showing all which tests are passed, at which stage it is failed, each stage what was the expected result and what was the actual result, and based on that you will prepare the test report. So by doing this, you have the end-to-end traceability, because the same workflow is taking or handling everything. So you will have the requirement ID created stakeholder, so from which you might have created two unit requirement, both are connected. Then from that you're creating the specification, again it is connected, so end-to-end traceability is also achieved. So with this we were able to achieve almost like a 70 to 80% reduction in the manual effort involved here, and end to end it is automated and with a completely ASPICE ready reports which you can use for your audit. Now what is happening in the background? So we were using the LLMs to understand the requirements, and to understand the requirements which are written in the natural language. And then we retained the context. This was one of the important things, that we have to make sure the test cases are generated with the context awareness. And then also another thing was a loop, or like a feedback mechanism, and iterative refinement, so that after every generation it is analyzed if there is any error, or if there is a mismatch, or it is using a different APIs, and using the feedback mechanism, it is refined. So we also use some supporting technologies for building it, and also like creating reports like Python, GCC compiler, Open PyXL, etc. So then, so for a case study, we have done, or like we have executed this on the AutoSACAN interface. So we had previously developed these modules like years back, and which was completely manual. So we have all the benchmark available for this module, where we know how the test cases should look like, how, what and all it has to test, what are the condition it should be testing. So we have a proper benchmark, and we took it as a case study to execute this automated. And what we had seen is, so we from the software requirement analysis, we created almost like 960 software requirements from the AutoSAR specification. And from that, 1689 unit requirements are derived using the AI agent. But when we return it from like years back as completely manual, it was 1846 requirements. So the numbers will definitely be a little different. That does not mean that it is inaccurate. The thing is, it is intelligent enough to combine things together and to avoid duplicates. And then out of that, 289 testable requirements were created. Previously it was 432, and in the qualification test it was 314 test cases, and previously it was 382 once we did it in a manual way, and end to end everything was traceable. So this is again something that I have already explained in the previous slide, how we have done it. So in a nutshell, what we are doing is we are loading the specification using the LLM. We are taking the requirements into creating our internal stakeholder requirement and making it in a clear structure. And then the parser will be applying, normalizing the words, removing the duplicates. Hyperlinks are replaced with the proper references. Like instead of having an hyperlink, it will tell, okay, in the section AB, para, etc. And then the requirements IDs are created. So for example, if you see the AutoSAR specifications, not everything will be having an ID. So maybe it is just under a heading, and some explicit requirement will be having IDs. So we cannot exclude none of them. So for traceability reasons, so for those sections also the IDs are created, and then it also mapped which section it is coming from. Then it is decomposed, as I mentioned previously. So made sure it is an atomic requirement, because we have to, once we establish traceability, it should not give a false positive that the traceability is there, but it is only testing the part of the requirement. So we made it atomic, and then it is checked again the consistency. So there should be a single action check, which means a requirement should be doing only one thing, not multiple things. Then it also verified about whether duplicates exist, any redundant requirements exist, and then again provided individual ID for this unit requirements. And then classifications, whether it's testable or not, and then the final specification is created in an Excel format here. So this is a screenshot of our tool, where we will be inputting the PDF document, the AutoSAR SWS PDF document, and then which will be in the first stage, where it creates the SRS Excel sheet, which is the internal stakeholder requirement specification, and that will act as an input for the stage 2, where this is loaded as uh, an input, and it runs the stage 2 and create the unit requirement Excel sheet. It's stuck, looks like. Excuse me. It's not moving. Thank you. Yeah, so this is the stakeholder requirement Excel sheet which was created. So you can see the sections and the pages, requirement IDs, and the description of the requirement. And this is the second stage output where you have further broke down the requirements into atomic requirements. Then you classified which feature it is associated to, and then whether it's a module functionality or information, and what kind of testing is required, whether it's a testable requirement or not. And it also have the traceability to the stakeholder requirement, which previously we had shown. So now this Excel, whatever we had shown here, this will act as an input. So input to the qualification testing stage. So first we will parse that Excel, then that will create the test cases. So for each testable requirements. And then the code need to be generated for the test cases. So there also we need to have a distribution. So here currently we are doing a manual configuration. So each test cases will also define what are the preconditions and what are the configuration dependencies it have. So looking into it, currently manually the configurations are created, and the tool is still intelligent enough to understand which configuration it has to use, and it will distribute the generated code accordingly. And it also uses the fix loop to loop through it and rectifies issues. And then it will be using the support of a built environment like some makefile, and it will execute or like build it on GCC currently, and then it will also create the log whether it's passed or not. And then if there are some compiler or linker error, it will also do a iterative loop to fix them. Then till stage 1 to stage 3, completely AI, and then from 4 and 5, there's a mistake, sorry. It is supported with the Python. So because it's more like copying the data into an Excel and creating the report out of it. So this is just the screenshots of whatever I have explained. So each output of each stage will act as an input for the next stage. And it will create, this is the test specification created. Here you will see test case IDs, which requirement it is tested, and what it is, a brief description about it, and what are the preconditions exist, and also which steps it follows. In each steps, it also defines what is the expected output. And so from that, it creates the test applications. You can see, maybe it's not very visible, like you can see here, it's creating different test applications, and then finally it will be like creating the report out of it. So this is a test case generated, not created. And this is the test report. Like you can see in each stage what is the expected output, what is the actual output, and comparing them. Like here you can see the expected invocation is 1, the actual invocation is 1, and what arguments are expected. Everything, it is every step it is validated, and accordingly each step the results are given. And the traceability metrics, this is from the stakeholder to unit requirement, and unit requirement to stakeholder, and unit requirement to test case. So this is bidirectional traceability. So as I have said in the beginning, so with this at each stage, so this is at the C1 stage, and also at C6 stage, and altogether we were able to achieve almost 75% of optimization in the human effort. So the main efforts involved manually is on the review, removing the duplicates, and also checking everything it the testable requirements, classification. So it's more on the review from the SME side. So yes, it also comes with different challenges that we faced during building this. So few of them are also listed here. So one is the LLM token window overflow, because once we parse everything together, the header files, the requirements, everything together, it is yeah, it happens that it overflow the context window. So what we did, we have broken down it into different chunks and prioritized and passed it in an order, so that way it was reduced complexity and we were able to maintain the context window. And then hallucinated API signature. So the generation was having some wrong signatures getting generated, so wrong IDs being used. So what we did is, like, we created a whitelisted signature and whitelisted IDs to be used here. And once the scripts are generated, also it went through a loop, or like a feedback mechanism, where it checks against the whitelisted IDs and APIs to make sure it's correct. And if anything is found wrong, it was mapped against the closest API. And then compiler and linger time problems. So that's where we were using the iterations, at least 4 iterations we used to knocked out every error. And then post-build configuration drift. So some cases, once we have multiple configurations, the test cases were generated with the wrong ID, which was set in another configuration. So this also, we took a support of Python scripts to map some configurations with the test cases, and by that, even that got eliminated. Yeah, so what are the benefits? We have already explained. Mainly, it's a massive effort optimization, and then it's a repeatable activity that you can run the same thing for the same other modules, like any modules that you take. You can just run it as it is, and it is giving a SPICE evidence ready report that you can directly use for your audit. So yeah, the future scope also includes use it for like functional safety aspects, doing the safety analysis, deriving the safety goals, and also further optimize it, like to achieve at least like 80 to 80% of efficiency. And then, as of now, as I have said, we were doing it manually, some of the configuration part. So that also we wanted to avoid. So there are many room for improvement here, and we have a clearly defined future scope for it. So with that, I'm concluding. I hope so. Yeah. Thank you.
Thank you very much. Wonderful. So we have time for questions. We can also ask in Chinese, so we have translation.
Hope there are no much questions, because I haven't done this by myself. But yeah, open for questions.
So from where did you travel here? Oh, there's okay. Yeah.
Thank you. So I have a question. So how to make sure the information extract from the input document every time is right?
So in this case, this was very easy for us, because the all case studies that we have performed is on set of modules or set of output that we already had, which was manually created, and it's already in production. So we have a very good reference that we can validate against whether the AI generated outputs are correct or not. So for example, some requirements which are classified correct, or like which are broken down correct, we have a good reference which is we can use and compare. And it involved manual effort, yes, but with that we have confirmed that the outputs are coming correct.
Okay, thank you.
More questions. Good.
Thanks for your presentation. My question is that, as shown in your slide,
after using the AI tooling, the effort was significantly reduced. So how can you measure the effectiveness?
So this is again effectiveness in the sense the effort optimization effectiveness you are talking, or is it about the
I mean
out?
the effort reduction. Yeah.
Yes.
Time
So
saved.
yeah, the time saved.
Time safety.
So this is again, as I have said, this was once done in a manually. So we have all the logs available. Like from if I look into my project report, I have the data telling that for each stage how many percentage of effort it was taken. So we have a reference from our data record. And now once we were doing this exercise, once not building the framework or like the prompt command or anything. So once we had the stable version, so once we started executing it, the first output came from this AI tool, and then refinement, like after doing the SMEs and reviewing it, refining it, the final stable output once we derived. So we also have the data of that effort. So this comparison is what I have represented here, and that's where we are seeing like almost like a 75% of efforts were optimized.
So your maybe your working time is record manually or automatically?
It is manual. I mean, in the sense, so each project we will allocate efforts and we will be monitoring them because we have to really track them whether we are underestimating or overestimating the resource allocation for that project. So we maintain that throughout, be it is this program or any program. So we maintain the effort planned and spent for a program.
So totally manually, right?
Yes.
Okay, okay. And another question is about your approach. So did you use the history artifacts, for example, the history requirements or test cases as the inputs of your tooling to generate the new one? Yeah.
No.
Okay.
So
totally.
templates, yes. Okay. So there are templates that we
Templates.
use from the, but nothing, no test cases are provided as a reference to generate.
Okay, so you just use the general large language model to generate
For
the
requirements,
attributes.
yes.
Okay. Okay, got it.
But the
Thanks a lot.
templates are provided as it was. That's why it is very structured in a way that we use. So the outputs that we came, it is in a way that our other products are being used. So the templates are provided. That was the input. Yeah.
Okay, thanks a lot.
But you didn't have like, I mean, typically when you want to make a test case generator, you need to have test cases as an input to train.
That's for the training, right? So yeah. So finally,
I
like,
think this was the question.
okay. Then sorry, I misunderstood you. I'm sorry. Yeah. Yeah,
Okay.
Definitely for training. Yes.
Yeah, so you had like your database of
Yes.
legacy test cases.
That's for like,
Okay.
we are also not planning to sell this as product because this more like work in a way that how our customer wanted to train it and use it. So we wanted to support building it and not just like build a product which is like you can use it for any framework.
Okay.
Yeah.
And then maybe just a logistical question. Maybe I missed it. Where is your company located in India?
So we are, our development centers are in India. I live in Germany. So we do have office in
okay.
Germany, USA, and Japan, and also in UK.
But this was the reason because the original speaker came from India. He had issues.
Nobody got visa from India, so I applied.
Oh, you don't get a visa if you.
Yeah, at the moment I don't know what's happening. So okay. I applied from Germany, so I'm here.
Okay, yeah. Okay, I see. Yeah. I see. Okay. Yeah, we have to fix this together. I mean,
maybe
it's not
rejected.
I mean, just for living, I think we need to.
It's still processing stage, so maybe there is too much application from India. I don't know.
Yeah. Okay.